Have you ever wondered why modern luxury Mercedes vehicles now rely on cameras and 48-volt electricity to read the road ahead, completely abandoning a hydraulic suspension system that was once the absolute pride of German engineering? Today, I'm going to tell you how one of the greatest engineering marvels in the automotive world turned into a terrifying financial nightmare. We'll look at how repairing a single system in these older cars can rack up a bill exceeding $8,500, sometimes costing more than the actual value of the car itself. We will discover the story behind the nitrogen gas spheres and leaking hydraulic struts. We'll explore how a system operating at an explosive pressure of 200 bars, using phenomenal sensors that make decisions in just 10 milliseconds, turned into a ticking time bomb that drained the wallets of older Mercedes owners. And through all of this, we will travel back in time to the 1990s to understand the root of the problem. We'll see how this whole nightmare started because of an impossible engineering dilemma that baffled car manufacturers for years. How do you build a 2-ton luxury sedan that glides comfortably over bumps, yet stays incredibly flat through corners without rolling like a purebred sports car? Let's dive into how Mercedes' sheer ambition to solve this impossible equation gave birth to the legendary ABC system. During the 1990s, Mercedes-Benz set out to address a long-standing engineering compromise. Conventional suspension systems require a strict balance between ride comfort and body control. Softer suspension improves comfort but allows more body roll, pitch, and squat under acceleration. Stiffer suspension improves handling and cornering but drastically reduces ride quality. Mercedes refused to compromise. They wanted a system that could deliver both, effectively defying the laws of physics for a heavy luxury vehicle. The result of this ambition was Active Body Control, or ABC. After several years of intense development, it entered production in 1999 on the C215CL class before expanding to the W220S class. Unlike conventional adaptive suspension systems that simply stiffen or soften shock absorbers, ABC used high-pressure hydraulics to actively control the physical movement of the vehicle's body. A conventional suspension reacts to changes in the road after they occur. A BC, on the other hand, continuously adjusted hydraulic pressure to counter body movement exactly as it happened. Hydraulic actuators worked alongside conventional steel springs, allowing the suspension to actively resist roll during high-speed cornering, completely reduce nosedive under heavy braking, and limit rear squat during aggressive acceleration. Mercedes proudly demonstrated the system through slalom exercises, emergency lane changes, and hard braking, showing significantly reduced body movement compared with conventional suspension designs. Contemporary road tests consistently praise the unbelievable combination of magic carpet ride comfort and sports car handling stability that ABC delivered. The anatomy of a mechanical marvel. The system depended on a massive number of complex interconnected components working in perfect harmony. The high-pressure pump supplied fluid to hydraulic struts at each wheel, operating at an intense 180 to 200 bars, roughly 2,600 to 2,900 pounds per square inch. The brain and sensors, ride height sensors, body acceleration sensors, steering angle sensors, brake pressure sensors, and an electronic control unit monitored vehicle inputs. Lightning-fast reflexes. Mercedes technical documentation states that certain control functions responded within roughly 10 milliseconds, faster than a human blink. Mercedes spent years developing what many engineers consider one of the most advanced suspension systems ever installed in a production car. However, decades later, that same system has become one of the most expensive maintenance concerns for owners of older Mercedes models. The reason was not a flaw in the concept itself, but the sheer complexity required to achieve its performance. As these vehicles aged, the complexity that defined the system drastically increased its maintenance demands. Every hydraulic line, seal, valve, sensor, accumulator, and electronic control unit represented another component subject to heat, pressure, and wear over time. Here is what typically goes wrong. explosive hydraulic leaks. The system relied on high-pressure fluid passing through hoses, fittings, and valve blocks. As seals aged, leaks inevitably developed. Worse, if the hydraulic fluid became contaminated, it had the potential to act like liquid sandpaper, destroying additional parts of the system from the inside out. The ABC spheres, hydraulic accumulators. Each accumulator contained nitrogen gas used to stabilize the immense hydraulic pressure. As the gas gradually escaped over time, owners frequently reported a harsher ride, terrifying bouncing, and unstable hydraulic pressure. These are now regarded as standard wear items. Pump deterioration. After years of operating under 2,900 pounds per square inch, internal pump components deteriorated. The pump could no longer maintain the pressure required to hold the heavy car up, leading to bright red warning messages on the dashboard and completely collapsed suspensions. Clogged valve blocks. These assemblies contained microscopic precision hydraulic valves responsible for directing pressure. Wear or microscopic contamination could result in uneven ride height, a car sagging on one corner, slower suspension response, or persistent fault warnings requiring highly specialized diagnosis. Sensor failures. Incorrect readings from aging ride height sensors caused the control system to miscalculate the vehicle's position, leading to improper leveling and erratic suspension behavior. Hydraulic struts were among the most complex and expensive components to replace. Each strut combined a conventional steel spring with an integrated hydraulic actuator. As internal seals deteriorated and leaked, replacing multiple struts often became a financial ruin for second or third owners. Independent Mercedes specialists commonly estimate the repair costs for parts alone as follows. Replacement hydraulic struts, $1,000 to over $2,500 each. Hydraulic pumps, $800 to over $2,000. Valve blocks, from several $100s to well over $1,000. A complete restoration of an aging ABC system can easily reach several $1,000s. Some owners of flagship V12 models have reported repair totals exceeding $10,000 depending on region, labor costs, and the use of new or remanufactured components. While Mercedes consistently presented ABC as a technology focused on ride comfort and safety, specifying strict periodic replacement of hydraulic fluid and filters, many independent specialists argue that neglected maintenance is the main culprit. Delayed fluid changes place fatal stress on the system. However, even the most meticulously maintained systems contain a large number of specialized hydraulic rubber parts that inevitably dry rot, age, and fail. Learning from the long-term realities of the ABC system, Mercedes continued developing the technology, shifting away from pure high-pressure hydraulics. In 2013, the company introduced Magic Body Control on the W222 S-Class. The system added stereo cameras that physically scanned the road ahead, allowing the suspension to proactively prepare for surface changes before the tires even touched them. Mercedes famously described it as the world's first suspension with eyes. Today, current flagship Mercedes models no longer use that original engine-driven, high-pressure hydraulic ABC system. Selected models now employ E-Active Body Control, which brilliantly combines electronically controlled air suspension with a highly efficient 48-volt electro-hydraulic architecture, achieving the same goal without the explosive pressures and ticking time bomb mechanics of the 90s. Active Body Control remains one of the most ambitious and legendary suspension systems Mercedes-Benz has ever produced. It proved that the massive production luxury car could achieve exceptional, physics-defying ride comfort and body control. Yet at the same time, its long-term ownership costs serve as a stark warning about the ultimate price of highly complex engineering. The system achieved exactly the performance Mercedes intended, but keeping that dream alive decades later proved to be an incredibly demanding reality.